Hello everyone, Assalamu alaikum. Welcome back for another video in the series of deep learning. Previously, what we have learned is about what an artificial neuron is. We discussed about Perceptron along with its coding. We've also talked about what an artificial neural network is and how it works. More about this topic is yet to come, so keep watching. If you haven't seen the videos, I have given links in the description below. Now, in this video, I want to talk about the different ways we can train a neural network. So there's this online mode, the batch mode, and the mini batch mode. So we will be talking about this in this video. So all these modes, they refer essentially to how we utilize our data when we train a neural network model. So basically, how and in which order we read the data regarding the training epochs, and also how we update our model. So these are general concepts that apply to any type of neural network. Now, just to briefly recap our perceptron model here. So here is a sketch of our perceptron. What we compute is the net inputs, and then we update the weights. So here I mainly want to highlight what's going on again under the hood. So if we have a data set, let's call that data set D with n training examples and also n labels, where each training example has a feature vector x and class label y. So when we start training on this dataset, what we do is we initialize the parameters of perceptron. For example, we can set the weights to all zeros, and we can set the bias unit also to be a zero. So this is nothing new. This is just like a recap. And then for every training epoch, remember, a training epoch is one cycle over the training set. This is something we discussed before as well. But if you have any question, feel free to drop a comment below. Now, for every training epoch, there could be multiple ones. We can have an arbitrary number of training epochs. In practice, it really depends on the dataset. In deep learning, later on, it's not uncommon to train something for 100 or 1000 epochs even. It really depends on how difficult the problem is, and also for every training epoch, this is our for loop. Then we go through each example one at a time. So there are two for loops. One is over the number of training epochs, and one is over the data points in each round. And this inner for loop here, what it is really doing is it's just going from one training point to the next one, so one at a time. That's what's going on here. And the outer one, the training epoch one, once we complete going through the dataset, we start at the beginning again and go through the dataset again. So that's really what's going on here. So for each data point in the perceptron, what we are doing is we are computing the prediction. So y hat is our prediction via the net input, and then we have this threshold function or activation function, which in this case is the threshold function. Then we computed the error, and then based on that we update. So we update here the weight vector, and we also update the bias vector. So there are two updates. Notice that the updates happen after each training data point. So again, if I go to the first example, based on that, I compute y hat, compute the error, and then update w, the weight vector, and the bias unit. If I have done that, I will go to the second training example and do the same thing again. So I update after each data point. So this is called the online mode. So this is just a summary of what I had on the previous slide without any mathematical symbols. Just basically for each training epoch, we iterate over through the data points, compute the output, calculate the error, and update the weights and the bias. So this is general concept that applies to any kind of neural network, not only the perceptron. We have seen that in the context of perceptron, but this is something you can also, as you will see later, use for linear regression, logistic regression, multi-layer perceptron, convolutional networks, and so forth. And there are then some variants of that one. This is called the batch mode, and one is the mini batch mode, which are essentially modifications of that, and they have also certain advantages which we will go over in the next couple of slides. So this is one way you can utilize your data, but there are other ways. One is called batch mode, and the other one is called the mini batch mode. In deep learning, actually the mini batch mode is the most common one, and I will also mention briefly then why is that so. Let's take a look at the batch mode now, next to the online mode. So the difference here really is that how we update the model before we actually update it after each data point. So we will still use the same number of data points in the batch mode, but instead of updating after each data point, we collect some information first and then we do the update. So the update is only really after each epoch. Again, let's take a look at online mode on the left hand side. So for each training epoch, we go over the data points, and then you can see here inside each of the data point we update. On the right hand side, I have the batch mode. It's a little bit different. We still have a for loop over the training epoch. However, the difference now is that we will, let's say, initialize this placeholder here. It's delta, delta for change. So this is some placeholder here which I have for the weights and for the bias. And then on the left hand side, like on the left hand side here, I'm iterating through the data point. Also the same thing here, I'm computing the output on the predictions, same thing as on the online mode. Also I calculate the error, same thing. So that's all the same. However, the difference really is here in this step. So you can see here in the online mode, I'm updating the weight and bias directly. Here in the batch mode, I'm only updating my placeholders. So I'm just accumulating some error terms or some information, and I keep accumulating that until I iterate it over every data point in the dataset. And then based on that, after I finished iterating through the current dataset here, then I update the weight vector and bias. So you can see I'm using my placeholder here now, and to update these parameters. So I am updating both the weight and bias using these placeholders which have some accumulated information. What is the advantage of doing this? Let's say online and batch mode. So online mode is an update, one update at a time, so it can be a little bit noisier. The batch mode is a little bit more robust, you can say. So you collect the statistics or information from the whole data set before you do the update. The disadvantage is it's a slower mode of updating because you do only one update for each training epoch. On the left hand side, you do multiple updates each epoch. So on the left hand side, you can think of it as maybe a faster learning because there are more updates. On the right hand side, they have fewer updates. Each update takes longer because you have to cycle through the whole dataset before you make an update, but the updates will be more accurate. I will also show you some visualizations of that, how that really works in the context of, let's say, linear regression or real case scenarios. I would say neither of the two are very common in deep learning, and I will also tell you why that is later on, and will become obvious as well. In practice, there's something called Minibatch mode, which is most common one. I have one more note here about the online mode. In practice, we usually also shuffle the dataset prior to each epoch to prevent cycles. So sometimes it can happen that, for example, in the Perceptron case or some other case, that the algorithm gets stuck flipping back and forth. So empirically, it's actually better to shuffle the dataset prior to each epoch. You can also think of it if you have, for example, the iris dataset. If you just load it, the classes will be sorted by class labels. So you have 50 examples from class 0 and 50 from class 1, and then plus 2. And that is also not ideal because let's say this is my iris dataset. All these are class labels 0, and then you have class labels 1 and then class labels 2. So if you don't shuffle, the problem is the algorithm will only update based on the zeros. Maybe zeros are easy, so there's nothing happening, and then it sees a completely new class, and then it only focuses on getting these right, but then maybe it's getting some other ones wrong again. And it's usually better to have a better shuffling, a little bit more diversity, that you have zeros, ones and twos intermixed with each other. And also you have to prevent flipping back and forth. It's just good to shuffle it. Well, shuffling doesn't cost much, so in that way it's not a bad thing to do anyway. Now the online mode is sometimes also called stochastic mode, or in the context of gradient descent, which we will cover in another video, it is also called stochastic gradient descent. Now let's get to the most common mode of learning. So this is the mini badge mode, which is a mix between the online mode and the badge mode. So similar to the previous two modes, what we do is we initialize our parameters that we want to update the weights and the bias, and then we also iterate over the training epochs. But now that's new. What's new is we also iterate over mini batches. So what is a mini batch? A mini batch is a chunk of data set. So if this is my training set, you can think of a mini batch as a smaller chunk of training set. So this would be mini batch 1, mini batch 2, 3, 4, and so on. And what is the size of mini batch? Actually, it really depends on usually common ones you will find in deep learning or something like 32, 64, 128, 256, sometimes also 512. It really depends on also our problem. It's like a hyperparameter, something you have to try out and see what works. So there are some papers suggesting smaller batch sizes can accelerate learning because it's noisier, and the noise can help making these updates a little bit faster, so you have more iterations. Larger batch size make better use of GPU, but it's really something that depends on practice, and we will also talk more about that when we talk about a technique later on called batch normalization. In any case, so this is mini batch here, and it's then essentially used like batch gradient descent. So everything down here, this is similar to batch mode, except that you perform the batch mode on the smaller chunk node. So before, the batch mode was done on this whole training set. Now the batch mode is done on one chunk at a time. So you again initialize these placeholders, and then for each data point in the mini batch, you compute the prediction, calculate the error, update the placeholder, and then you update the weight and bias unit. So this way it would be similar to the batch mode, except that you use one smaller mini batch at a time, and this is usually the most common mode in deep learning. So as a question for you, do you have any ideas why that is? Maybe pause the video for a second and think about it and see if you have some ideas before I move forward with the answer. As you can see, I've written down 3 of the reasons why I think that mini batch is much more useful than let's say the online mode and the batch mode in deep learning. So one would be that when you are choosing a subset such as mini batch, instead of just one example at a time, we can take advantage of vectorization that we talked about in the previous video. So in the previous video, we had seen that we can compute things efficiently. So when we had, for example, a training matrix containing multiple entries multiplied by the weight vector, so if we had that, we could process multiple training examples at a time, which is then faster than in a for loop executing this multiplication with a vector. So instead of using a vector times weight matrix and doing this multiple times with a for loop is of course slower than doing it one time with this matrix multiplication. So using this vectorization makes everything, or makes the processing or iterating over an epoch faster in the mini batch mode compared to the online mode. Also, having fewer updates than in an online mode, like including more examples in each epoch, makes things a little bit more robust. So it reduces the noise a little bit. And also, compared to the full batch mode, like I said here in the point number 3, we have more updates in the mini batch mode if for each iteration over the epoch. So in the batch mode, we only have this iteration of the epochs and then only update once. So we apply this only once after each epoch. In the mini batch mode, we do that multiple times depending on how many mini badges we have in each epoch. So in that way, we have more updates than in the batch mode, which can also help with learning things faster. I hope this video was helpful and informative. See you in the next video.